Okay, 7.2 number 13. So with this one here, if you don't have graphing technology, which you don't need it, but you can use graphing technology to kind of see what's going on here. The absolute value of this quadratic function, so we're going to have some kind of quadratic that might be reflected or folded up on the x-axis, right? So let's check the intercepts. So the y-intercept here, that's when x equals 0. So g of x is going to equal what? When this is 0, 0 minus 8. So we have the y-intercept is absolute value of -8 or +8. Okay, so I'm going to draw a little sketch down here. +8. That's where our y-intercept is. Now the x-intercepts, how do we find that? Well, if you factor this, then it's going to be absolute value of, well, and we don't even need the absolute value sign because it's the x-intercepts don't change, right? So you could just factor the function like this. So it's going to be x and x. This looks like 4 and 2. So -4 plus 2. So that's an x-intercept of +4 and -2. Okay, 4, -2. Okay. So that's the x-intercepts are -2, 0, and 4, 0. The y-intercept is 0, 8. Graph the function. Okay. So if we have a parabola and we know that this has been reflected up, these are the intercepts. So a rough sketch will give us something like this and something like this, right? Those are the intercepts. Instead of going down like this, like it would normally do, it's absolute value. So guess what? It pops up and goes through 8. So it looks something like that. There's your absolute value graph. Okay, I'll just get, if you guys are working on another question, I'm going to get you to listen for this part, okay? The domain and range is very important. So the domain and range for this one, now that's what I want to focus on, and then the piecewise functions. So C and D are super important because we don't talk about this very much, so I'm just going to run over it here now. The domain for, really for this kind of thing, there are no restrictions for x, right? X can be anything, it's a polynomial. And if you look at this, the x could be anything from -infinity to +infinity. There's no gaps. There's no asymptotes. Do you guys know what asymptotes are? No. Okay, I'll teach you that later. There's no restrictions. So D is an element of x is an element of all real numbers. Okay, there's no restrictions. The range now, because this is all flipped above the x-axis, you see that? What's the range? Yep. Y has to be greater than or equal to 0. And if you put this y-er at the end, that's great. You don't have to though. I don't require that. So is everyone okay with the domain and range there for those? And it is easy after you've graphed it for sure. Yeah, that's why it's down here for C, because you've already graphed it, so it's easy to see. Now the piecewise function. So let's get over this one here now. G of x is going to be made up of, and this is what's hard to understand, of 2 different parabolas. Okay? I have outlined, I will right now, outline the first one. That's the positive version of what's inside the absolute value brackets. You see that? So the positive version of this would be this parabola outlined in yellow. So I have this going on. I have, what is it? No, x squared, positive x squared minus 2x minus 8. Right? That's the positive version of this. Now the one highlighted in blue would be the negative version, and a piece of this function is part of the negative version. You see that? That comprises this piece of the overall function. So that's why I write the negative version. You can use brackets if you want. That's great. And leave the signs the same. I don't care. If you distribute that through, that's great too. So that's the easy part, the positive and negative versions. The difficult part, or the tricky part, is you have to now state on which domain or what part of the domain does this actual g of x graph look like the positive parabola or the parabola that opens up. So to do that, we would look again at the yellow graph. So what's actually part of the yellow graph? This arm and this arm. So that part is where x is less than or equal to -2 as a domain. See? It's this part of the domain, because that's what corresponds to this arm. and then x greater than or equal to 4, because that's what corresponds to this arm. So comma x greater than or equal to positive 4. So that's how you identify the domain in these piecewise functions. I'll do it again for the negative part so you can maybe see that a bit easier. But the negative part is this. This is the negative part, right? Uh-oh, my computer's lagging. If it crashes on me, you'll know why. So here, watch this. The negative part of this function is between negative 2 and positive 4. It's this part of the domain. That's where it corresponds to the negative parabola. So I don't know if you remember this, but to write this between negative 2 and 4, you could write negative 2 here, positive 4 over here, the x in the middle, and then you would do less than, less than. This is called, is it set notation? Something like that? Anyways, have you seen this before or no?
Yes.
You have? Okay, hopefully you remember that. So that's the tricky part of this question. Expressing the domain for which g of x is actually defined by this piece, and the domain where g of x is actually defined by the positive piece. Question? Was there a hand there? No, you're okay? Okay. Anybody else have any questions about that? Now, somebody double check the back of the book there. This should be your answer here, I think.
4.2.